Hello friends, I am Vijan Valubari. All are welcome to my YouTube channel. In this 27th video on railways, we will see the features of permanent way. Also, we will see the different types of patrol undertaken by railways, especially this engineering department, to ensure the safety of the railway track. Okay, now we will go straight to the diagram. The track on which the trains are moved is normally called the permanent way. Why it is called the permanent way? Because as the name denotes, it is permanent. Suppose a train which is started from this station A towards B station, and it is moving in this section. If there happens to be an obstruction, suppose there is a rail crack or there is a tree fallen, the train cannot shift its movement to a side and can again go to this track. It is not possible, whereas in the case of road traffic it is possible. That is the main difference between the road traffic and rail traffic. The way for the train is permanent, that is the permanent way. Now how this permanent way is constructed? We just take a portion of this track here. So the track will be like this. Here this is a double line from A station to B station, this is up line, and from this direction from B to A, this direction is down line. So a portion of the track, let us see. It is two rails running parallel connected by sleepers, and these are iron rails. These sleepers are normally PSC sleepers, nowadays used. PSC means pre-stressed concrete. Pre-stressed concrete sleepers are used, and these sleepers are connected or fixed with the rails using clips. These clips are called pan-roll clips. Pan-roll clips. These clips are called pan-roll clips. Pan-roll clips will be like this, and using these clips, these rail and sleepers are connected. This distance between these two sleepers will be normally 60 centimeter. That is, from the middle of this sleeper to the middle of this next sleeper, the distance will be 60 centimeter. So this is the plainly speaking what the track will be. If it is broad gauge, then the distance between these two rails will be 1.673 meters. Nowadays the used rail will be 52 kg or 60 kg per meter. That is, a meter of this rail will weigh 52 kg or 60 kg. That means the rail will be very heavy, and it is not possible to easily move these rails. These rails are manufactured in steel plant, and from the steel plant it is to be transported to the location where the track is laid. So for transportation, if the rail is very much lengthy, it is not possible. It is not maybe with the machines it may be possible to load and unload, but in the location and also for repair works, it is not possible to move it so easily if it is very much lengthy. So the manufactured rails from the steel plants will be 13 meters in length. A rail length means 13 meters. While using these rails for laying track, three rails normally welded together to have a 39 meter length rail, and that is called a SWR. SWR means short welded rail. This short form of SWR we are using in the case of station working routes also. Okay, here this SWR means short welded rail. So short welded rail means three 13 meter length rails welded together to form a 39 meter length rail. So that 39 meter length rail will be called SWR. So previously we were using this SWR extensively for laying this track. These 39 meter length rails will be continuously joined. This joint of these rails is normally called fish plate joint. fish plate joint. So fish plate joint will be like this. Here two iron plates will be joined together with these rails through nut and bolt, and this is called a fish plate joint. Fish plate joint will be like this, and here there will be a gap given. This gap is given so that during daytime this iron will expand, absorbing the heat from the sun. This iron will definitely become hot and it will expand, and during expansion this will expand towards this side and this rail will expand towards this side. In order to give room for this expansion, this gap is given between these rails. Nowadays, instead of this SWR, we are using LWR. LWR, that is long welded rails. Long welded rails will be having a minimum length of 250 meters. And again, we have progressed. Nowadays, we are using LWR, long welded rail, extending from station A to station B. That is, from the entire block section, we are using a single rail. That is, the entire rail from one station to another station is continuously welded. So that is how nowadays we are using LWR. So when this LWR is used, there is another problem. LWR is a short rail, so the expansion will be less. Whereas the LWR, it is lengthy, even kilometer length. LWR is there, single rail is there, so the expansion will be heavy towards the ends. So in order to give room for this expansion, at the end of the LWR there will be a joint called SEJ. SEJ means switch expansion joint. This is a switch expansion joint. If you view from the top of this rail, you can see the joint will be like this. That is, when the rail is got heated, it will move towards, or it will expand towards this direction. So here gap is given. In the same way, here when this rail is expanded towards this direction, here gap is given. So the switch expansion joint will be normally like this. You can see this picture also. You can see the gap is given on either end for expansion. So SEJ will be normally there at the end of a long welded rail. There is another term usually used in permanent way, that is continuous welded rail. Previously, this LWR used to go extensively towards the station, and also it will go beyond the points also. Nowadays, this CWR is not there, only LWR is there. We cannot use CWR, that is, we cannot have continuous welded rail through the station, because station yard, you can see the signals, points, etc. are interlocked, and there will be track circuiting. Here this electric connection is through the track. So if the track is going continuously throughout, then it is not possible to have separate track circuited portions. So here we are having joints, several joints will be there, and these joints will be nowadays glued joints. These joints are nowadays glued joints. You can see here it is a glued joint, will be like this. Glued joints are normally insulated to have this track circuiting and also this interlocking. So the joints in the yards will be normally glued insulated joints. From the home signal towards this direction, there will be a stretch of line which is called a calling out track. Calling out track. When the train has reached this portion, the station master can easily understand from the panel that the train has arrived. This calling out track was 3 rail length previously, that is 39 meters. Nowadays we are having calling out track which are 5 rail length. That means here 5 rails will be welded together to form a calling out track. While the track is laid down, there will be several bridges in between. Here it is a bridge between station A and B. In the bridge, in the pillar, there will be a red mark that is painted. A painted red mark will be there, and that is called the danger level. That is, if above that mark the water rises, means train running should be stopped. That is the danger level. Above danger level, train should not be run. Another white mark will be there, which is called high flood level. High flood level mark. High flood level means in the history of this bridge, what was the highest level of the water on that bridge? That is marked as high flood level in white. High flood level will be marked in white paint. That high flood level may be below this red mark or above the red mark. See, like the bridges, there will be causeways in railways. Causeways. What are these causeways? Suppose the track is to be laid near a bund or a water logging area or near a pond, very big pond, etc. It will be, normally such area will be low lying. In such areas, railway will lay track on a raised earth bed. Here in this picture you can see water is there on either side. In between this water logged area or water filled area, an earth bed is built on which a track is laid for the passage of the train. Such a path or such area is called causeways. So during heavy rainfall, water will get filled in this tank or filled in this waterlogged area, and it may threaten the safety of the railway track. Suppose here there is a big waterlogged area, and here railway has built track on a raised earth bed. Here there is a chance that during monsoon the water may damage the track or water may go over the causeway. So in such areas, a flat bar will be fixed by the railway to understand the level of the water. In such areas, when water has risen to the ballast level, there is no problem. But when water has risen above ballast level but below the rail level, then two men have to pilot this train. So two trackmen will be piloting the train from this end to this end. Suppose here the water has gone above rail level but below flat bar level. Below flat bar level. In that case, SCPV has to give a certificate to the loco pilot, and he has to pilot the train from one end to the other end across the causeway. If the water has gone above flat bar, in that case, train service should be stopped. So these are the situations under which the train is operated in causeways. Now we will come to the patrolling of the lines. These are the 6 types of patrolling undertaken by the engineering department to ensure the safety of the track. Railway is running trains 24 hours, so it is to be monitored and ensured that the track is safe for the passage of each and every train. It is 1. Daily patrol by keyman, gang patrol during abnormal rainfall, monsoon patrolling, hot bar cold weather patrol, watchmen at vulnerable places, and security patrolling. So these are the different types of patrolling done by railways. Now in this we will first see daily patrol by keyman. A group of engineering staff, around 20 to 30 staff, will be headquartered at different locations in the open line. That is, it may be at block stations or at flag stations or CNC stations. And these engineering staff are called trackmen. And that group is called gang. This gang of trackmen They will be having a head and he is called gangmate. Gangmate. The seniormost person of this trackman, he will be undertaking the duty of keyman. So there will be 1 or 2 keymen in the gang. The daily patrol is undertaken by the keyman. That is, suppose let us take, here we are having a gang at station A, 20 to 30 people are there. They are having one gangmate as its head, and also one keyman is there. What he will do? He will patrol this line up to a specific length. He will patrol, and then he will shift to this line, this up line, and he will patrol towards this direction. This patrol is undertaken daily. In other words, the entire track in Indian Railways, except light sections, the entire track in Indian Railways will be patrolled by keyman at least once in a day. While patrolling, he will see that the track is intact, there is no rail crack or rail fracture, anything like that, and he will see that the keys, I told you earlier, that is patrol keys are there connecting this rail with the sleepers. Those keys will be tightened. He will be having a hammer with him, and with that he will tighten these patrol keys. And he will see in unmanned LCs, between the check rail and the main rail there will be stones, and these stones will be removed. Inspect the bridges and the causeways. All these things he will inspect while patrolling the line. Once in a week, this daily patrolling duty will be undertaken by the gangmate. On that day, the gangmate duty will be undertaken by the keyman. Keyman will be having a small tin containing 10 detonators with him. So in the backpack of this keyman, these detonators will be there, and it is to be used during emergency. That is, if the train is to be stopped, suppose he is patrolling this line, he finds that there is something wrong with the track, train should not be allowed to pass this area because there is a rail crack or something. What he will do? He has to protect the train. Here there is the problem with the track. From that obstruction, from 600 meters from that obstruction, he will place one detonator. Then 1200 meters from that obstruction, that is 600 meters from this detonator, he will place 3 detonators 10 meters apart. That is how he will protect the train in case of emergency. These are the duties of keyman. I told you that is a tin of detonators will be with the keyman, and it will contain 10 detonators. From the date of manufacture, the detonators are having life of 5 years. After 5 years, 2 detonators from that batch of detonators will be tested for its efficacy. If it is exploding, then it is okay. The life will be extended for 1 year. And next year also, they will test 2 detonators from that batch for its efficacy, and the life will be extended for 1 more year. In this way, for 3 years it will be extended. That is, the life is 5 years, it can be extended for 3 years, and after that, that is after 8 years, these detonators will be discarded. I told you after 5 years, 2 from the batch will be tested. This testing will be done by exploding it under empty wagons. It will be done by inspectors. While exploding, it is to be seen that all are standing 45 meters away from this detonator. That is 45 meter radius is the safe distance for these detonators. Or after placing the detonators, they must stand 45 meters away from it. We have now got a fair idea about the permanent way. Also, out of the 6 types of patrolling undertaken by the engineering department, we have gone through only the first one, that is the daily patrol conducted by keyman. The rest of the types of patrolling we will see in our next video. And also some of my friends have raised some doubts regarding the subjects dealt earlier, and those doubts also will be clarified in the next video. Okay, see you in our next video.